All right, so when we look at this one again, the f of x's domain is going to be all real numbers, right? I can take any number, plug in for x, square it, get any number back, okay? But for g of x, there's an issue there, right? If x is 7, we run into a problem, right? If x is 5, we run into a problem, right? Okay? So that second g of x, we got to remind ourselves that x being less than 7 is a problem. Okay? So those are problems. And maybe we write it this way. The domain, so g of x's domain is x greater than or equal to 7. Okay? Because all we're doing is we're taking the x minus 7. Say it's got to be greater than or equal to 0. Solve for x. Now, am I going to use this domain in its entirety when I start doing these composition functions? I don't know. Okay? It just depends on what the final production of the function looks like. But when the g of x becomes the input value, I do know at least I have that condition. Okay, that's going to exist. So let's just do, let's go f composed of g. So it's going to become f of root x minus 7. Okay. Now I'm going to go to f, and wherever I see x, I'm going to replace it with root x minus 7. So it becomes square root of x minus 7, now squared, right? Okay. What's going to happen with those roots and powers of 2? Cancel out, right? It gives me x minus 7. Okay. So that's my final composition. That is f of g of x. Okay. Now, I look at that and I say, well, there's no domain issues with x minus 7, right? It's linear. Okay. But the first thing we should do is look at the input function. That input function is a requirement for our domain. And that input function says that x has to be what? Greater than or equal to 7. Okay? So x has to be greater than or equal to 7. And then I'll look at this. So that is one requirement for my domain. X has got to be greater than or equal to 7. And then I'll look at the final composition, and there are no additional requirements, right? No additional restraints on the domain. Okay? So this is the only issue with my domain. So that becomes then the domain for f of g of x. X is greater than or equal to 7, or write it that way in interval notation. So that has to be maintained for that function. If you were to graph that, okay. Now here's the thing: you can't, because they're composition of functions. What I want you to understand is that there is a difference. Coming to get you, Zach. There's a difference if I start off with just x plus 7 as my answer, right? Okay. There is a difference between knowing that if f was, what was f? F was x squared, and g, come on, g is square root of, was it x minus 7? Okay. There is a difference when I compose them, f of g of x. Okay. And we just get that blue line instead of x minus 7, which was that line. Does that kind of make sense? Okay. So there is a difference in what we're doing here. We're not just interested in just finding what this final rule is and starting off with that final rule of x minus 7. We want to know that, or realize that there were some restrictions on the inputs that we started the problem off with, and we have to maintain those as we go through the problem and find our final result. Okay. Okay. Now they don't simplify here in GeoGebra, but we can see that would simplify to x minus 7, right? but then we keep the domain restriction of x has to be greater than 7, greater than or equal to 7. If we do g of f of x, g of f of x, okay, so it's going to be g of x squared. So now I'm going to go to my function x squared minus 7. Does that kind of make sense? Okay, so I took that x squared and I came up here, and where I saw my input value of x, or my variable, I just replaced it with the new input of x squared. So that is my new function. Now this one's a little bit maybe stranger to kind of deal with, but let's think about the domain restrictions. Okay, were there any domain restrictions on input, on the first input? None there. Okay, so we're fine. The second thing is to look at your final one. So, okay, what are the domain issues there? Okay, well, here's what we got to do. We got to take x squared minus 7 and do what with it? Make it greater than or equal to 0, right? Okay, the input, or the radicand here has to be a positive number for square roots, right? Or 0. So that's why we set this up. And now I'm going to say x squared is greater than or equal to 7. So x has got to be greater than or equal to,
Plus or minus the square root of 7.
Plus or minus the square root of 7. Okay? Well, that's kind of weird. Okay? Because when we do this, we really get two solutions here, but I don't really necessarily read them both as x is greater than radical 7 and x is greater than or equal to negative radical 7. So I don't necessarily like that. What I like is to think about it this way. Instead of actually solving the inequality, because there's really more to solving that inequality than what we just did. It's a nonlinear inequality. I like to do it this way. X squared minus 7 is equal to 0, right? So x is going to equal plus or minus radical 7. I just found the roots, or the zeros of this function. But I also have in my mind what this thing should have looked like. Is that a transformation of x squared down 7 units? So that looks something like this. Okay, so 7's down here. That's what that graph's going to look like, correct? Okay, so the roots I just found are right there and right there. That's root 7, and that's negative root 7. Is that okay? We want to know for what x values is the curve, the parabola, above 0. Well, isn't it above or equal to 0? Right there and right there, as well as there and there. Does that kind of make sense to everybody? Okay. So, those are the values that we're interested for a domain. X has to be to the left of negative square root of 7, and it has to be to the right of the square root of 7, which I don't think you get, and I know you don't get, and this is why we don't do it this way. X squared minus 7 greater than or equal to 0. We solve that using the square root procedure or method. If I say it that way, x is greater than or equal to the positive 7, radical 7, and x is greater or equal to root negative 7. Well, if I think about what that looks like on a number line, if there's negative root 7 and there's root 7, doesn't that look like this? That kind of makes sense? Where really we wanted that, didn't we? Okay, that's what we've got written over there in red. And it has to do with the way we did this here with dividing by a negative and flipping inequality signs, that kind of stuff, but or multiplying by a negative. If we were to graph these, maybe you're not confident in what you've done. Graph the two things, okay? And you should be able to do this on your TIA 3 as well. If I want to go, so this was f of g, so we want g of f, g of f x. Okay, with that purple function, you see that purple function, okay, if I look at that point right there, okay, square root of 7, what'd you say it was, 2.7? Jared? Okay, so that looks like about negative 2.7, right? Looks like about positive 2.7. And we're seeing that the purple curve then is existing to the left of negative 2.7 and to the right of positive 2.7. Kind of make sense? We haven't dealt a whole lot with nonlinear inequalities, and you solve them completely different than what you solve a linear inequality. And it goes, we have to do some factoring, we have to set what we call a sign chart. We'll get there, we'll talk about that kind of stuff, but I really haven't dealt too much with it so far. If I ask, so those are the two composing of, f of g and g with f. Let's go f of f. This one should be pretty easy. We have f of, now x squared. So now I go to this function where I see x and replace it with x squared, so it becomes x squared, which becomes x to the fourth, right? Well, x to the fourth has no domain restrictions, has no problem with that. And x squared, for the same reason, has no domain issues. So the domain for my final composition is all real numbers. Okay. G of x is a little bit different. G of x. Okay, that's going to turn into g of the square root of x minus 7. Okay, and then that's going to become, okay, the square root. So this square root that I just drew is this outside function g. And that outside function g there. And now I'm going to go into where I see x inside of g. I'm going to replace it with radical x minus 7. So we get radical x minus 7 minus 7. Okay. That's ugly, and it doesn't really get any nicer by, that last question we did where we take the 1/3 and the 1/3 the cube roots and make them 1/9. You really can't do that here real nice because of this minus 7 out here kind of hanging out by itself underneath this one radical. But again, okay, we want to think about the input. The input here, that thing has to be greater than or equal to 7, right? Okay, so that's important. So x has to be greater than or equal to 7. But now, in our final composition, doesn't that thing have to be greater than or equal to 7? Or sorry, greater than or equal to 0 as well? Because it's under another radical. So I'm going to go to the side. I'm going to do root of x minus 7 minus 7. I'm going to make that greater than or equal to 0. Okay. Add 7 to both sides. Square both sides. Add 7 to both sides. Okay. Now it's saying x has to be greater than or equal to 56. Okay. Now we've got a couple of restrictions here. This first one, because of the input, said x had to be greater than 7. Okay. So the only way that I can get basically something as a result here is if that first becomes basically a real number, right? Okay, I want to force that to be non-imaginary, and that happens at values that are bigger than 7. Okay, but now because we got the minus 7 in the other square root, okay, once I'm okay with a number providing a real number back here, and that's what these here are going to do. They're going to provide a real number back underneath this first inside square root. Now we subtract 7 from that and take the square root again, and it's saying those types of numbers, the only other types of numbers you're going to get back there are bigger than 56. Okay? So what we look at here, what we want is what we call the most restrictive domain. And the most restrictive means the one that kind of kicks out the most values, and it has to be numbers that are bigger than or equal to 56. Does that make sense? So we go 56 to infinity would be that solution. Because if I choose, let's just maybe choose a value, I don't know, maybe an easy one here. Let's go 49, 7, Let's do 36. What's 36 minus 36? Let's go 43. Let's say x is 43. Okay? X is 43. So it'd be a number kind of right there, right? So let's say that is, let's get rid of this circle here. If I'm allowed to use 43, plug that 43 in right here first. 43 minus 7 is 36. Square root of 36 is 6. So this thing here changes to 6. What's 6 minus 7? Negative 1. Can I take the square root of negative 1? No. So that's why 43 doesn't get involved in my final domain. Okay? But once I start at 56. 56 minus 7? 49, right? Square root of 49? 7. 7 minus 7? 0. Can you take square root of 0?
Yes.
You bet. Okay, and that's the first value that we start using for the domain of g of x. Okay? I think that of the ones we've done, that's probably one of maybe the harder ones in regards to domain, because of how we've got to think about that inside function here, that root x minus 7 minus 7 in our final composition.